So hi everyone and welcome to the demo session of ThreeFold. So for this week, we will explore Terraform and OpenTofu on the ThreeFold Grid.
All right. So our agenda for today is to briefly check out the manual, of course, as we always do. We'll introduce Terraform and also OpenTofu, a brief demo to show you how you can use it, and then we'll have some discussion at the end with any questions. Actually, we'll flip up the order a bit here. I'll show you the manual after telling you a bit about Terraform and OpenTofu. So Terraform is the industry-leading infrastructure as code system. It allows declarative administration of cloud infrastructure, enabling automation, visibility, and control of deployments. So in our threefold universe, Terraform is a way of creating deployments on the threefold grid. And it's cool that we have this because it is a very industry standard tool, and it gives a bit more power than what you get with the playground, our dashboard that is, but it's also a bit more accessible than working with the APIs and the SDK software development kits directly. So Terraform kind of sits in this middle place between the graphical browser-based deployments and doing everything in code. So Terraform plugs into those APIs on the back end, and it gives a way to work with those using relatively simple configuration files, which we'll be seeing soon. OpenTofu, on the other hand, is a fully open source work of Terraform. It was inspired by the shift of Terraform to a source available license. Source available is a form of license that means that the source code for newer versions of Terraform is still available, but it's not freely, the code's not freely available to use in the same way that an open source license provides. There's now some restrictions around the use of Terraform, especially in commercial contexts. So OpenTofu was created by a group that's organized through the Linux Foundation as a fully open source fork, continuing the sort of tradition of Terraform, providing a compatible tool to work with Terraform that is fully open source and allows everyone that was using Terraform before to continue what they're doing without needing to worry about running into potential licensing or legal issues after the license change. So that's OpenTofu. We've been testing it a bit. I'm going to actually show OpenTofu today. But as far as I've seen, basically everything works the same, command for command. You just need to change the Terraform command into the tofu command. So far, everything seems to work the same. It's fully compatible. Few key features and benefits of both Terraform and OpenTofu. So you define your infrastructure in config files. These are using a domain-specific language known as HCL, HashiCorp Configuration Language. That's what you're seeing over on the right side. So this looks kind of like JSON or something like that. It's not a full-fledged programming language, although you do have some ability to do some loops and things like this. So if you were with us last time or saw the demo from last time about Pulumi, this is one of the main distinguishing points, is that Terraform is only working in the HCL. There's actually some effort to expand Terraform to be using other languages as well. I'm not so familiar with that, but generally speaking, everyone is working in HashiCorp config language. It does have some nice features, as we'll see. If we're doing things like pulling in a file for the SSH key, which we can see down here at the bottom. So there are some more programming language-like features that are in here. It's not just data, like these files are somewhat dynamic. And from your file, Terraform generates an execution plan that shows you what is going to happen before you actually commit to the step of doing it. There's state management, so Terraform is always keeping track of the current state of your deployment, if it's existing, if it's up, if it's destroyed, and what all the variables are that are being returned from the cloud provider, which in this case is ThreeFold, which we'll be seeing a bit more about that later. If you want to make any changes, Terraform will reconcile and apply those changes. So that could be things like adding new VMs or new disks or things to your deployment. Our ThreeFold Terraform provider is somewhat limited in what it can do in terms of making updates. So that's one limitation. There's some things that you can do and ways you can get around this, but that's inherently limited by the way that ZOS is working. And in the future, that might be different. We might have more flexibility in terms of being able to change deployments. But there are some tricks today if you need to update or modify things. There are some ways around it. I won't go into detail on that today, but we have, I'm not sure if we cover that in the manual either. I think I've written about this on the forum. Of course, feel free to ask your questions at the end or in the grid testers chat, or hit me up via DM if you want to know more about how to do some more advanced use cases with Terraform, which definitely unlocks compared to the dashboard. And another thing that I won't show today, but is possible, is that you can use secret management within Terraform to sort of store and maybe encrypt any secrets you have on disk and then inject those into the deployment so that they're not just sitting around in plain text files on your machine. This is especially important in more like corporate contexts where you need to control more secrets and things like that. But even for personal use, this can be good practice. So those are some features that are there or out there. I'm going to show a pretty small set of features today, but if you want to know more, I encourage you to dive into the manual, dive into Terraform documentation and learn more. So let's get on to the demo now. First, I want to show the manual as I promised. So if we come in here to manual.grid.tf, documentation, system administrators, Terraform, we'll have some table of contents here, introduction. You can read a bit more about Terraform, learn how to install it. For OpenTofu, we're not covering that yet, but for OpenTofu, it's opentofu.org. You can go there, grab the install instructions. On my Arch Linux machine, it was as simple as installing it from the package manager. I'm guessing probably in newer versions of Ubuntu, you also have OpenTofu in there. Maybe not, haven't checked that yet, but there should be install instructions for all the major platforms. One thing I'll mention, Terraform is supported by Windows, and our Terraform plugin is also theoretically supported on Windows. My more recent tests have not been successful. I think we have some things to fix there, but in theory, at least, we should have support for Windows. If you're running Windows, you might, these days, it might be better to use Windows Subsystem for Linux and install Terraform in there, or OpenTofu. I'm not sure about Windows support for OpenTofu, but I guess it's there as well. Okay, so that's up to you. Get it installed. And from there, we can go and check out some examples in the repository. There's also some guides and examples here in the manual. So you can come in here for like the full VM deployment. This is a self-contained guide that includes like the main.tf file that you need in here. And then if you're looking for more, the complete reference is going to be here on the repository, code repository, ThreeFold Tech, Terraform Provider Grid. You could also get here from the manual. Like if you click this deployment examples, that's going to take us into one of the subfolders here, which I'll show you in a sec. There's some basic information here about how to use the provider. This is already included in the examples. You don't really need to worry about that. one thing I'll note is that this version number is old, so ignore that. Using the provider is mostly what would be relevant for us today. So there are a few ways that you can specify your mnemonic seed phrase and the network that you want to deploy to. One of them is specifying these as environment variables in your shell. And then another way, which I'll be showing as well, is to write them directly into the configuration file, the main.tf file. There's another way, which is using like a separate variables file. I won't show that, but just to say that there are a few ways to do this. And this is showing you the basic lifecycle commands as well, init, apply, and destroy. I'll be demoing all of those. This is just a basic reference, like the quick start, basically. If we come into, there's two important things here, docs and examples. If we come into examples, we can open resources, and there's a number of different examples for deploying VMs. My example today is roughly based on this single VM, Mycelium. And there's quite a lot of others as well. So you can check out these examples, and any example in here just has a main.tf, which includes some example config. If you're not seeing an example that shows you exactly what you need, or if you just want to come and check this out, there's also documentation here, which covers all of the inputs and outputs for every object that we have on the grid. So this is a deployment. This is kind of the main thing that we use, and this is where the VMs go. This can be a bit overwhelming if you're looking at this. So maybe the thing that I like to normally do, if we just come in here and to like open up one of these main.tf files, we can look like, we'll see, we're looking at a grid deployment and a VM, and maybe I'm wondering like, what other options are in here if I wanted to add a public IP or something like that. And that's where I can come over here to the documentation. I'm inside the grid deployment resource here. And if I scroll down to VMs, then I can see like, oh, here's a public IP or public IPv6. These are Boolean values, which would be true, false. So I could come in here and add that. So that's how I work with the documentation, and everything's in here. We show the inputs that you can provide, and then also there's read-only things, which are the outputs that we get after the deployment. So some things we need to specify, like whether we want to have a public IP, and some things Terraform is going to tell us after the deployment is completed, because that information is only available at that time, such as what is the public IP that we managed to reserve. So that's going to be in a read-only output. So that's all noted in here, and I'll show you how we use these in practice here in the demo. So what I have on screen now is, on the left side, a main.tf file. On the right side, I have a shell where I'm going to run some commands, so we can be looking at both things at once. And all that's in here now is this main.tf file. There's nothing hidden, nothing sneaky going on here. So we just start with the folder with the main.tf file, and always the first thing that we want to do is a Terraform or a tofu init. So in this case, tofu init. And what it's going to do now is check the file for the providers that we need, which we've specified up here in this block that we need ThreeFold tech/grid provider. It's going to go and find the latest version and install that for us. If there were any other providers needed, it would install those as well. And for deploying to mainnet, this is all that you need to know. Just use this from the examples and go ahead and init. If you're deploying to testnet or devnet, you might need to specify a version number. Go ahead and check out the repository again for more information about how to do that. It's not always totally clear if a newer version, like a pre-release, is needed for DevNet or for testnet. But if we go and check out the repository, we will be able to see that they're working like on this version 1.11.2-dev. So if I wanted to test with DevNet, I would probably go for this one instead of the main release that's here that we're getting. So just a note there about versions, but generally speaking, if you want to deploy to mainnet, you can just take the latest published version. That's going to be fine. All right, so let's just take a brief look at what happened when we did that, which from the surface level looks like not much, but if we look also at hidden files, we'll see there's now a lock file and there's also a Terraform directory. And I don't want to go too deep here, but if I run a tree, we'll basically just see like this Terraform directory has a providers folder. It has an OpenTofu.org folder, it has ThreeFold tech folder, and the grid plugin. So this is basically all that we did with init is just install the plugin into here. And we don't need to worry about that as we're using OpenTofu or Terraform, but I just want to show that quickly so that you can see what is happening when we do the init. It is installing the latest version into our local folder here. So this also means that you can have multiple folders with main.tf files and different versions of the Terraform provider. And that means that you can sometimes end up with an outdated version that no longer works. So in that case, you would want to do a tofu init dash update, I believe, or update, upgrade. Upgrade. And in that case, it will upgrade the plugins.
And even though you use tofu, it's still a Terraform file. So that's where we see it say it's very similar to using Terraform.
Yeah, so actually, I would be careful about this, but I actually have I mixed up the commands a bit at sometimes, and it seems to all work. Like you can switch over to writing Terraform. And yeah, that folder is still called Terraform because that's what's expected. So everything is more or less compatible. We're using OpenTofu plugin directory, but it still works if you want to switch back to Terraform. All right, so enough about that. Let's get a bit more into the action here. So just checking out this config file, we'll go through it briefly. We have a provider block here for the grid. This is always going to be required even if it's empty. And this is where we can specify our network. As I was saying before, we can also do this in a environment variable. And if we wanted to, we could write our seed phrase in here like this. Mnemonic x equals here. I'm not going to do that, of course, because I don't want to show off seed phrase here in the demo. But just to point out that that's one way you can do it. That's kind of the simplest way. If you want to, again, we saw if you want to do it through an environment variable, you can use that export form that we saw on the repository README. Locals is a way of defining some local variables. We'll show more about this later. This local's name is being used in a couple places below, like here and also here. So this is just a way that we can write this name demo in one place. And then if we want to change it later to be like OpenTofu demo, we can just change this and it will automatically get changed in locations below. So that's nice. Write that change. So here we have a grid network. This is going to be required in most deployments if you have VMs. If you only had ZDBs, I think you can avoid this.
And you can take space with the name. It doesn't matter.
We'll see if it works.
Oh yeah.
It should. I don't know. We'll find out. We'll try it. Doing it live. So our network has a list of nodes that are included in the network. It has an IP range. This you don't need to worry about too much. in this case, we're going to add WireGuard access. So this is nice. It handles everything for you automatically in terms of finding a gateway node. So in this case, node 1 is a gateway, but if it wasn't a gateway, the setting this add WireGuard access to true would instruct Terraform or plugin to automatically add a gateway into your network. So that's cool. You don't need to worry about including the gateway explicitly in your nodes list here. And a description. You can write whatever you want there. Go wild. Now we have a resource. So one thing I'll point out is that when we define resources, there's two strings that follow the keyword resource. The first one is the resource type. So if you remember, we were looking at the repository documentation. This is the resource name that's given there. And then we give a name for this particular instance of this resource. So this is just the way that Terraform operates. If every time we define a resource, we write the word resource, we write the name of the resource that we want, and then we write the type, the name of the type of resource that we want, and then we write the name that we are giving to this instance of the resource. So above we see grid network net1, down here, grid deployment D1. All right, the name, we're going to use the same name here. For the deployment, we will deploy this onto node 1, and it's important that the node that ID that we specify here is the same, or is included at least in our network here, because we are going to specify this network. Within Terraform, we can reference a resource by just writing the name of the resource category or class here, grid network, and then we can write a dot, we can write the name, same name that we saw up here, one, and then we can reference its name. So we can do this for any of the items in the list here. And this will just insert that name into the spot here. We could also just write the name, which is going to be OpenTofu demo in this case. And it's okay that we're calling our deployment and our network by the same name. That won't cause us any conflicts here. All right, for our VMs, we'll also give the VM name. We specify which flist we want to use. I'm just using our base image, which is an Alpine-based flist micro VM image. Number of CPUs, the amount of RAM, entry point, and environment variables. In this case, we're just using SSH key. And like I pointed out before, this is a nice thing we can do in Terraform where we just give it the path to a file, and it will take the contents of this file and insert it automatically, which is nice because if we want to share this file around, then anyone that has an ID rsa.pub can use this file without needing to change it, versus if we were to actually write our SSH key in here, then anyone using this file would need to modify it. We can, I'm not sure if we can use this as an environment variable in our shell, probably, maybe not. If we wanted to add other environment variables, we could include those here as well, just on a new line like this, or whatever. Down below, we're going to have some outputs. So like I was mentioning before, we have some things that are only known after the deployment is created. And these are some of those items, and outputs are how we're able to print those sorts of values to the screen. So we give them a name. This is just a name to refer them to. And then we say, what is the value? So like we saw above, here we're just referencing into our grid network resource type, or net1, based on the name that we gave it above. Access WireGuard config is the name of the output that we're looking for. And I can show you again here in the docs that if we want to look at a network, then we can see that access WireGuard config is one of the read-only items that we have in the list of documentation here. So these are all the things that are available to us after we create the deployment. So if you're curious about what we're able to use, that stuff's all in here. All right, so that's instructing Terraform to print the WireGuard config to the console after the deployment is created. This is a similar structure for the IP. In this case, this is the WireGuard IP, and then we're also going to print the console URL that will enable us to view a virtual console in our browser for this VM if we wanted to. That's usually only interesting for like debug purposes, or if you were deploying FLists that don't have SSH and you want to be able to view output on a console. That was here in the example. I just hung on to it. We'll show that today, though. These are the most important, the WireGuard config and the IP. Okay, so to deploy this deployment, we're going to write tofu apply. We could use auto approve. I'm not going to write that at first because I want to show everything that we need. Okay, so we can't write a space.
Now we know.
Now we know, yeah. It's only alphanumeric characters and underscores, so we could put an underscore. Okay, let's try again. This is one nice thing about Terraform and OpenTofu is that if you have certain sorts of errors in your config, it will show you that before you go to create deployment. So now we're seeing our deployment plan. It's going to show us everything that will be created. We can see like here my SSH key has been populated, so that's cool. We wanted to verify that that's correct. And down here at the bottom of the screen, it's asking us if we want to perform these actions. I can just type yes. Only yes, not Y or yeah or anything like that. Must be Y, yes. And OpenTofu in this case will start creating the deployment and giving us some updates about the status. This happens pretty quickly, so all right. Our apply is complete. We have added 2 resources, our network and our deployment. And here's our WireGuard config. Here's the IP of our VM, and let's just confirm that we can connect. So here I'm just going to write this WireGuard config into a file quickly and use WireGuard quick up to bring up the network. This is just a quick way to do this on the shell, but it's not anything special. If you're using WireGuard in the graphical interface, you could just copy this WireGuard config into graphical interface and pull up your tunnel that way.
And here you exported the mnemonics?
Yeah, I already did that in this terminal before.
All right.
Yeah, before we started. So yeah, thanks for the question. So once again, if you need to understand how to do that, it's here on the repository. So you can just write it like this, just like up here. So yeah, write your words in here. And then once you export that, then for the lifetime of the shell, you'll be able to apply and destroy without needing to worry about inputting your seed phrase again. And once you get a new shell, you'll have to do that again, which is kind of inconvenient. So that's why you might want to either put them directly into the file, like I was saying before, write them in here, or do something more advanced with the variables, which you can reference in the manual. The full VM example there shows you how to use a variables file, which is a bit more secure because then if you're sharing your main.tf or putting it into version control on GitHub or something like that, then you don't have your seed phrase in there. It's in a separate file. That's nice. But yeah, for purposes of demo today, I just wrote the I wrote my seed phrase into an environment variable in this shell before the start of the demo.
All right.
Okay, so now I'm going to SSH to this WireGuard IP, and everything looks good. This is an Alpine Linux VM, and oops, ping ThreeFold.io. Looks like website's up, so that's good. And yeah, now you have your VM. You can do whatever fun stuff you want to do in here. Go ahead and disconnect. Now, when we're finished with this deployment, we can go ahead and destroy it. So I'll show that. Oops, what did I do? Whiteboard. Kill this and stop sharing. Excuse me, everyone. I was just moving around my
No worries.
toolbar.
Yeah, we see it now. We see the whole screen.
Okay, that's good.
Well, there's a little bar in the middle of it.
Yeah, there's a funny black box.
It's gone.
Still there for me. Oh well. Well. Okay, so when we want to destroy the deployment, we can go ahead and just write tofu destroy. In this case, I'll show you how auto approve works. It's going to skip the step where we have to type yes. Like at the apply step, there will also be a plan created at this point. In this case, it's not going to stop and show us the plan. It's just going to continue right on. But here's the plan. And basically, all these little red minus signs mean that all this stuff is going to go bye-bye, being our VM and our network. So we can say goodbye to that stuff. The destruction happens pretty quickly. It's basically just canceling the contracts, and then ZOS will tear down the VM and that stuff. So that's a simple deployment process. Let's go ahead and clear this one again. Now what I want to show you is kind of the power of Terraform in terms of what it allows us to do. Like let's say that instead of one VM, I now want to have two VMs. So what I can do is come over here and just copy this block here, and now we will have a new VM. So I will change the resource name here to D2. We can actually continue with this same name as far as I know. I don't think I have to change that. Let's put this one on a different node, which would be node 8. Once I've done that, I will need to come up here and make sure that node 8 is inside my network, because if it's not, then that's not going to work. And I'm using the same network for two deployments, and this is for two deployments and for two VMs, and this is something that we can't get with the dashboard, at least not now. Let's also rename this VM to VM2. And one other thing I wanted to do here is show how we might want to use a variable to change or to specify and maybe later change the F-list that we're using in both deployments at the same time. So what I can do is just cut this F-list link and come up here to the locals and make a new local for the F-list. And I'll put that in there. Quote mark. So now I have a new local named F-list, and then what I can do is anywhere that I want to input this F-list link, I can go ahead and just write local.flist. And then go ahead and do the same thing here for both F-lists. So if later, I wanted to change this deployment to be two Ubuntu VMs instead of two Alpine VMs, then I can just come up here and in one spot, I can change the link to the F-list, and that will propagate to both locations below. And I like to do this for other things too, like sometimes the CPU and the memory quantities. Um, we could also use variables like for the node IDs. This is another one that I think is a nice example. Like I could do something like node 1 equals 1 and node 2 equals 8. And then like here I could write local node 1 and local node 8. Change this one, 1, and this one to be local node 8. Oops, node 2. Maybe I should have called those A and B or something. So now what I've done is I've specified the node IDs I'm deploying to as variables. And this is nice because now if I want to change this from node 8 to be, say, node 13, I can do that. And now the
On
network
that
will
line
up.
too, it's node 8.
Okay, so, and I should point out that Terraform would have, or OpenTofu in this case, would have called me out on that one, but we have, thankfully, I have a winter, that's what I call it, in the audience. So thanks, Meek. We didn't have to see the gnarly error. So in this case, now I can, so this is nice because now I don't need to worry about going through the file and changing every instance. I can just change it in one spot and it gets changed everywhere below. So this is cool. And let's go ahead and try deploying this and see what happens with two VMs. So I will write tofu apply again. This time I'm going to do auto approve, speed things up a bit, and we'll start deploying two VMs, hopefully. All right, so we can see now in our plan that we have deployment 2 and deployment 1.
And if we wanted, let's say, to have the output for the second VM, we could add it in the output section, right?
We could, yeah, you're ruining my surprise here, Meek.
Oh no.
So, okay, our deployment's completed, but oh no, we have only the IP address
Oh
for
no.
VM1 and not for VM2. So this is actually something that I did by mistake the first time, but I thought was nice to show that if we forgot to do something like that, we can just come in here and we can change the files. So I'm going to go ahead and copy these and make a set of new outputs for the new VM. So we'll just change the name and then we'll change the deployment number to match. And here we're referencing the first VM in this VM section. So if your deployment has multiple VMs, you could use 0, 1, 2, 3, etc. here. Yeah, so now we can change this and go ahead and save this file. And then when I come back here, what I can do is just write apply again. Oops, I have to change the name on this one.
So we can see the errors from Terraform OpenTofu are very clear, right?
Yeah, so this is nice. It's going to show us where we're going wrong and give us some clear instructions on how we can fix it. So when I apply again, in this case, it's not going to change anything about our deployment because all that has stayed the same, but we'll just see that we have some changes to the outputs here. So now
That's
it's going
nice. That's
it's
nice.
going to show. All right, so this is cool. Now we have both of these IP addresses. So let's try, well, now we have a new WireGuard network. So what we'll need to do is bring down the old one and do the same dance here, write a new config, bring up the new WireGuard network. And then we can SSH to, oops, do that. Let's get the IP address for VM2, WireGuard IP, and SSH root. All right, so now we're connected to the second VM. And one cool thing about having two VMs in the same WireGuard network is that assuming that there's a path for these two nodes to be able to talk to each other, which in this case is the fact that both of these nodes have a public IPv6 address. If you're working with two hidden nodes, like two nodes that are at home and behind firewalls, this won't work out of the box. It might work if we have the WireGuard access point in there. There's some caveats here, but assuming that you have a configuration group of nodes that supports this, then we can connect directly between the nodes. So I can ping VM1 from VM2, and this is a way to create a secure private network for our VMs to communicate with each other.
Nice. So it's a VPN built in.
Yeah, this is
amazing.
Yeah, so every VM deployed on the grid becomes part of a WireGuard network, but generally it's just a one of one type of thing, and it's not particularly useful except for allowing users to access. I mean, that's a big use case, of course, allowing the user to access the VM over the WireGuard for SSH or for other purposes. But this is a cool thing that we can do with Terraform, is put multiple VMs into the same network and allow them to talk to each other.
So for example, now we could have a database and sync the two nodes with one another. They know how to talk to each other, right?
Yeah, for sure. So your two VMs could be your web server and your database, and they could, the web server could be exposed to the internet, accepting incoming connections, and your database could be only available over that WireGuard connection for added security. It would be like one potential use case. Or yeah, you could have a database with a replica that is being synced over WireGuard. That would be another use case for sure. All right, now we'll go ahead and destroy this deployment as well. That's going to be basically just like we saw before. We'll see that OpenTofu is always going to be checking the current state before it goes to apply any changes. So that's this thing that we were talking about before, where you specify the final state that you want to be in. It's going to look what is the state that we're in now and create the plan for how to get from A to B in terms of what needs to happen in order to create the end goal that we're looking for. In this case, the end goal is that all VMs are deployed or are destroyed, and we're not getting billed anymore. Everything's cleaned up. All right, so that was the demo.
Nice.
That's Terraform. Does anyone have any questions?
Peter, maybe? I saw you talking. We didn't hear you. You were muted.
No, not really. Thank you.
All right, all right.
Just overwhelmed because that far exceeds my knowledge.
Have you tried Terraform so far on the grid?
Yeah, I've come across Terraform a while ago, but never put my hands on. So I was just curious how that's implemented on ThreeFold.
Of course, if you give it a try, you can ask for help. We'll be happy to help you with this.
I tried to make it as unscary as possible.
Absolutely.
It's really not so bad. I got started with Terraform after I joined ThreeFold, and it can be a bit intimidating. Parts of it that I find to be a bit unintuitive, like the way that the resource types and names are specified, and the fact that you have like this name and then this other name, and there's some weird things about it, but once you kind of get over that or just accept that it's how things are, then it's a nice, powerful tool if you want to go a step beyond like what's available in the dashboard. But on the other hand, if you don't need anything more advanced, then dashboard is really nice and convenient in this thing. So yeah, use what works for you, I'd say.
But as you showed, it's the fact that you can deploy different VMs and then have a WireGuard VPN connecting the different nodes. That's something very useful, depending on what you want to do on the grid, that you wouldn't get necessarily with the dashboard. So it's fun to know.
Yeah, for sure. We're not able yet to do that in the dashboard. Maybe one day it will be there. The other thing that I mentioned briefly that you can do with Terraform that you can't do with the dashboard is upgrading deployments. Like I said, we don't have, it's the way that you're able to upgrade a deployment is if you have a VM with a disk attached, you're able to detach the disk and keep this around and take the VM away, and then bring up a new VM with different resources and reattach that disk. So the end result is that you have a new VM that has all the same data and higher, like greater specs if you wanted more CPUs or whatever. But the way that we have to step through that, given the constraints of the grid, is to do this destroy and recreate process. But that's a very powerful thing that you can unlock if you're working with Terraform.
So let's say with your last demo, when you had two VMs, could you have added another VM, a third VM, and then you just redo apply, and then it would deploy the other VM?
You can, yeah. The thing that I'm not 100% sure about is what happens with the network. If it's possible to update a network to include a third node, but if you wanted to make a new VM on one of the same be in the network, that definitely works. I feel like it should be possible to add another node into the mix like that, but I'm not 100% sure. And that was one thing that occurred to me. It would be nice to show, but I didn't have time to.
Yeah, there's a lot of stuff to explore on this. So one day at a time.
Yeah, for sure. And the plugin will tell you, OpenTofu or Terraform will tell you if you're trying to do something that it's not able to do. So that's nice.
Yeah. So any other questions? Well, any questions, of course. All right, guys. So thanks for being here for this demo session, and we'll see you later for an upcoming demo session. We'll maybe take more time to explore further features of Terraform and Pulumi to show more complex deployment. So now with this demo session and the last one we did with Pulumi, you have the basic to deploy some very nice workload on the grid. So I hope you enjoyed and see you next time.
Thanks, everyone. Good to see you all.
Thank you.
Thanks, Meek.